the storm update is actually expensive, right? And you're doing it so many times every second. So that's why this thing is slow. That is, the updation is slow. This to render this itself, right? This is an important thing. This is an important topic to discuss because microtasks are used a lot of times. So what is a microtask? How does it differ from a regular task? All that stuff. So let's just first of all cover a bit of theoretical part, and then I'll actually make you see in the code as well how this works. So you know that when you use things like set timeout and set interval, those things are scheduled as tasks in the task queue, right? And we discussed how the call stack works, how the task queue works. So whenever you put in something like, just calling a set timeout, that's how the call. And when I start both, every time the call stack gets empty, that is, set timeout, set st counter gets called, set, you can see from the code, let's go ahead and start the set timeout counter. You can see it's rapidly, see from the code that set timeout recursively calls itself with just an increment in the value. And whenever it calls, I'll set the text. And when does it call? Every time the call stack gets empty. That is, set timeout, set st counter gets called, set timeout places it on the call stack, on the task queue. This function exits, call stack picks up this function right here, this part. It calls this function, which calls this function, and you know the process from the last video. So that's how you make something like this, right? On the similar hand, if you actually, I have the wrong button name, but again, this of your system, yeah, I need itself, right? Already. So let's start, right? And here we go. Is, but it differs in a couple of ways, which is going to make a lot of difference, right? So let's start with a very simple question. What I'm going to do first of all is, actually, let me just go ahead and remove this function. I'm just going to make a single function, and I'm going to say this is something like schedule, schedule work, right? And here we're going to make sure that we call some functions which process as task queues and some which process as microtask queues. So I'm going to call set timeout with, let's say, console.log first, and I'm just going to call it immediately on the task queue, right? Then second, and then let's say I have a promise.resolve. Promises work on task queue, on microtask queues, right? So whenever you call a .then on any promise, that at that particular time, whenever the promise is resolved, it's going to place this function on the microtask queue, and it's going to execute whenever the event loop gets some time to execute the microtask queues. So I'm going to say console log first from microtask, right? And then I'm going to say second from microtask as well. And let's just create a button real quick here and say with me. I can just say that document.getElementById button, just attaching an event listener. On click, I want to call the schedule work, and that should be it, right? So now let's just go ahead and see this very simple example first of all and see what happens. So I'll click on this, and we have this order, right? So the first thing which is clear from this output, even if you click it multiple times, you're going to see you always get the microtask output before the task queue output. Now why is that? Well, that is because when event loop is running, event loop is something like this. You can think of event loop like this, and it's doing a bunch of actions. So it's doing step 1, then it's doing step 2, then it's doing step 3, and if you consider like step 2 to be check for task queues, then step 1 could be check for microtask queue, right? So this is why whenever you click on this, you're gonna see event loop always checks microtask queue first, and then it checks the task queue. Now, mind you, the difference here, it might not be clear eventually, but this is something you should know. The thing is that microtask queues are always evaluated in the first, in the single event loop take. By that, what I mean is that you see when this code was being called, that is when I clicked on this button, schedule work, what happened was I got something like this. So set timeout was called on task queue. So task queue looks something like this first, second, right? And then the microtask queue look like this. First from microtask and second from microtask, right? Now pay very close attention to what happens here actually. When the event loop is running, that means when this while thing is running, let me just go ahead and copy this actually right there. When this while thing is running, what's going to happen is that it would try to completely exhaust the microtask queue array, right? So you see that what's going to happen is that in the step 1, it will keep checking for the microtask queues, right? So it will keep on checking the microtask queues once. So what happen, let's go ahead and copy this second from microtask, right? Now pay very close attention to what happens here actually. When the event loop is running, that means when this while thing is running, let me just go ahead and copy this actually right there. When this while thing is running, what's going to happen is that it would try to completely exhaust the microtask queue array, right? So you see that what's going to happen is that in the step 1, it will keep checking for the microtask queues, right? So it will keep on checking the microtask queues again and again and again and again, just to see if there's any pending task there or not. So it's going to first of all do this, then it's going to do that, right? But with the case of task queues, what really happens is that it runs only once per event loop cycle. That means this would just happen just once, even though there's a second task pending, but this would happen in the next iteration of the event loop, right? It would not happen in the single iteration, it would happen in the next iteration. So how do we do that? How do we see that effect? Let's see. So I'm gonna go ahead and create another timeout, but this time, this timeout would actually set up a micro task queue task, right? So let me just go ahead and comment this out for the moment. And I'm gonna say first from micro task again, this is 0, and then what I'm gonna do is this would be second from micro task, and then what I'm gonna do is probably, yeah, I mean, we can just do one more thing to make things really interesting, and that is something like this, right? So it's really something now. So here we are, 0, and then 0. I hope this is not confusing. This first set timeout is for this thing, and I think we have some syntax wrong somewhere. Yeah, that should fix it. So we have basically 2 set timeouts. Let's just see what's happening. Let's just see what happens when I click on this. So I click on this, you see we get first and second as the output, but we don't get anything else because obviously we are not resolving them, because, you know, just like I said, micro task queues are always fired when you resolve them. So I'm going to say, yeah, I mean, we already have the value, right? So we can just go ahead and get that value. So here we are, right? So now if I go ahead, refresh this, click on this, hold on, let's see what happens. Let's see what really happened. And I think we have a second nested. All right. Now, what the hell actually happened here? Well, you see, we started executing this function. So I'm just going to create a task queue here real quick. And I'm going to create a micro task queue as well, so that it's easier for us to, you know, just keep the check. So on the first go, a task queue schedules this console log, right? Now I'm not really writing the whole function. In a sense, this would be the whole function which would be placed on the task queue, but I'm just skipping that so that it's cleaner. And then it also places the second on the task queue. Then what it does is that it places this promise on the task queue, not on the micro task queue, but on the task queue, because it was called by set timeout, right? So I have something like, I'll just shorten it down to by set timeout, right? So I have something like, I'll just shorten it by on the task queue, not on the micro task queue, but on the task queue, because it was called by set timeout, right? So I have something like, I'll just shorten it down to this thing, right? So that it's again easier for us to manage. Then again, because we have a set timeout, this goes to the task queue, not to the micro task queue. And then finally we have something nested, so this whole thing goes to the task queue. So at this point, our task queue, our micro task queue in fact is completely empty, right? Now, what happens is in the next iteration, what you're going to see is only first is taken out. In the next iteration of event loop, only first is taken out. So it's taken out. It's console logged, as you can see on the screen, just like fine. In the next iteration again, it is again taken out. That is, you know, second is taken out. So we get second on the screen. Now, what happens is that we have first from micro task. That is, you know, again a single task is taken out and it is placed on the micro task queue. So we get this first from micro task right here in the micro task queue. But at this point, you know, what's going to happen is that obviously micro task queues are checked before the task queues, so the iteration again ends for this thing. But when it begins, it's not going to place it right now. It's going to actually try to exhaust the micro task queue first, right? So it's going to pick this up from the micro task queue and console log it, just like you can see. Then in the next iteration, it's going to pick up another task. In this case, our second from micro task, and execute it. It sees that it has to put it on the micro task queue, but because the micro task queue work is already done for this part, it's going to iterate to the next cycle. It's going to see micro task queue is empty or not. Yep, it is not empty. Let's just go ahead and pick that stuff up, and you can see that we get the second from micro task. And then finally, you know, this just places this thing again on the task queue in one cycle, right? And then in the next cycle, this places it on the micro task queue, and then finally you get the output, just like you can see, right? So this was a very simple example on task queue and micro task queue working together. In the next videos, you're going to be seeing more such examples so that it's absolutely clear to you how the context execution works. So if you are confused right now, do not worry, because we'll be seeing a lot of examples where it will be absolutely clear for you how the task queues and micro task queues execution really work. So that's all for this video. I'll see you in the next one really quick. Alright everyone, welcome back. And in this video, let's just take a look at this example where we're going to be seeing that how the execution order would look like, and it's going to clear a lot of doubt for you again. If you're coming from the last video where you are slightly, perplexed about how this whole thing works, fear not, we're going to be seeing this example and we'll be taking a look at the whole solution for this. If you have a pen and paper or whatever you prefer, try to calculate the output order for this thing, and if you could calculate it correctly, well, good work. But yeah, let's start and see how this would look like. So I'm going to click on this, we're going to get an output, and then I'm going to explain how we got that output. So here we have it. We have M1, M2, T1, all this output, and M is for micro task queue stuff, which is called with the promises, and T1 is the task queue stuff. So let's see how we really got this output right here, right? So when we got our code, problem stuff to solve. That is the first thing. We got M1 and M2 scheduled on the microtasks, right? So I'm going to create a microtask queue, microtasks as M1 and M2 at the moment, right? And the task queue, tasks as, whatever we'll get. So the next line is T1 on the task queue. So here we have the task queue as T1, right? And one important thing, I'm not really mentioning it right here, our call stack. Our call stack right now consists of schedule work, right? Because this function is being called right now. Remember, microtask queues and task queues would always be checked, would only be checked when our call stack is empty, right? They would never be checked if our call stack is not empty. So that is something you should keep in mind. If you have a bunch of functions in your call stack, and if you have a bunch of functions in microtask queue as well, JavaScript would make sure the call stack is empty before it actually calls any of the task queue or microtask queue functions. So this is something you should keep in mind. But yeah, so we have this thing, we have task as T1. Then the next thing is a little bit challenging because we have this whole function block. So what JavaScript going to do is it's not going to care at all what's going on in this function, and it's going to throw this whole thing inside the task queue. Why? Because set timeout places stuff on task queue, and that's all you have to worry about initially. Then again, we get set timeout, so it would be T2 and T3. So I'm just gonna, just write it as T2 and T3. So this is a situation right now. Schedule work ends, call stack is empty. Now it's time to run microtasks. Why? Because microtasks come in the first order, like before the task queue is executed. The browser is going to start working with microtasks at this point, and it's going to start exhausting the whole thing, right? Just like I said, with tasks, what happens is that we pick up a single task and then run it in the next iteration of the event loop. But microtask queue, what happens here is that the browser would try to exhaust this whole thing before it moves on to task queue or before it moves on in general. So our code is kind of synchronously blocked here inside the microtask queue. So if you have some microtasks which can further just push microtasks in the queue, you can have an infinite loop. For example, if M1 pushes M3, if M2 pushes M4, this could just go on forever because browser is going to execute M3 and M4 as well, which are going to put more tasks, so it could go on forever, right? But in our case, it's just output, so we don't have to worry a lot. So we see M1 is the first output, which is exactly what we get, right? So I'm going to remove this. And then next we get M2 because, just like I said, microtask queues are going to be completely exhausted before event loop moves forward. At this point, event loop sees that, hey, microtask is gone, so let's move. Then it sees that, task queue also has tasks, so it picks up only one task, mind you, only one task, not more. So it picks up T1, and you can see you get that output, and that's it. The event loop runs the next cycle now. It sees that the call stack is empty, it sees the microtask is empty, time to pick up something from task queue. So it picks this up, and what happens, it executes this by bringing it into the call stack, right? That's like how things happen. At this point, what happens is that it sees that you are placing a lot of things now on the microtask queue. So it's going to place them all, M3, M4, M5. And as you can see that call stack is done, task queue has already done its one, M3, M4. M5. And as you can see that call stack is done, task queue has already done its one task per event loop cycle, so it's done as well. It's going to repeat, the event loop is going to complete, whatever is left, and it's going to run again. But this time you see microtask is available and task queue is also available. But just like I said, microtasks are exhausted fully, not really, just once at a big neat output with you. So I hope this example cleared out some confusions you might have from the last video. If not, don't worry, we're gonna have one more video showing, a little bit more complicated example, but hopefully that will clear out everything you have, left so far. So yeah, that's all for this video. I'm going to see you in the next one really soon. Alright everyone, welcome back, and this is going to be the ultimate example for you, which is going to clear out a lot of things if you have so far in mind about task queues and microtask queues. So pay very close attention to this if you ever have, if you still have any doubts about the execution order.
Mahen! 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 এদিকে না চোখ ডাকতে যখন চোখ না জানাটা অফ করতে তেসোটা আর
Mascando, vamos já, vamos.
You see, the code we have is pretty much similar from what we had from the last video, right? Let me just go ahead and throw in a bunch of console logs, hello from main thread as well, right? So that we can discover. Everything, but you see that I have two similar looking functions, with the only difference being, the first one has number 1. Assigned to it in the console logs, and the second one has number 2 assigned to it all over the place, right? Otherwise, both of them are similar. And what I'm doing with them is that I'm attaching them as event listeners to the same button. that is our click me button, right? But I'm doing one more thing, that is I have another button which says programmatic click, and what I'm going to do with that is I am clicking button 1 when I click button 2, but I'm clicking it using JavaScript, right? So it's going to be fun to see actually how this differs. So let's start this video, let's start the whole execution thing, how that would all work out, and let's get into it. So this is our page, and we have two buttons now. You see I have click me and programmatic click. So let's just go ahead and click on the click me first and see what's going on. All right, so we have this much output, and let's just try to figure out how we got this output. So I'm going to create an output here, which is going to be just, for our reference so that we don't really lose anything. So first things first, what happens when you click on the button? Scheduled work is called, right? It is dispatched by the V8 engine internally, and this function runs. So this function goes on the call stack, number one thing, right? This function execution starts. We get this promise.resolve on the microtask queue, just like we discussed. There we go. Then we get the number 2 on the microtask queue. Well, nothing surprising here. We know that. We all know about that. Then we get set time mode scheduled on the task queue. So there's that, right? Then we get this set time of call, right? So we get this whole big function call scheduled on the task queue, because this function is not executed yet. It's just scheduled to be executed. Then finally we get another T2 right here on task queue one more time, and then we get T3 as well on the task queue. And mind you, none of this is actually executed at the moment. It's just waiting inside the queue. But this console log which we see, it gets executed. Why does it get executed? Because it's obviously on the main thread, right? So you're gonna just see this as the execution, as the first execution. So we get this hello from the main thread, and you can clearly see that this is something we get from our actual output as well. All right. At this point, you're gonna see that scheduled work is done, and call stack becomes empty. And what does it mean when call stack becomes empty? You know about that. Yes, the first step is to check microtask queue, right? So even though we have a pending listener here, and actually let me be just actually clear about this. What happened when we click on this was not like it was actually magically appeared on the call stack. It was actually placed on the task queue, right? So it was placed on task queue like this, right? Initially, then scheduled work was picked up, and it was placed in the call stack. And when it was done, it was done. But now when the execution resumes, you see that the scheduled work again is sitting in the task queue, but we do not run task queue before microtask queue, right? So we run microtask queue first of all, and here we are. We get the first output like that, right? Which you can see right here as well. Then we get the second output as well, like this, which you can see again right here. And microtask queue is empty at this point. Now you see, whenever you click on the buttons, just like I said, I missed it actually earlier when I was actually showing the function distribution, what's going where. But when buttons are clicked, you're gonna see the events are placed on the task queue. They're not directly brought into call stack, right? So scheduled work was placed in the task queue. It was brought to call stack. It was done. Now it's time for scheduled work again. And just like task queue works, it's just going to bring in one function, execute it, and be done with it. But scheduled work again, what it does is that it basically does this whole thing again. It will just place number 2 on microtask, number 2 again on microtask. This would go on task queue, right? This would, again, this whole block is going to go on the task queue. And then we finally have these two things as well on the task queue. Number 2 T2 and number 2 T3. And I think I made, no mistake, that's fine, right? And then finally we get to the main thread, and because main thread is main thread, it gets executed. So we get this order. You see the 4 statements, the first 4 statements are same as ours. All right, so again, scheduled work again ends at this point. Call stack becomes empty, and when call stack becomes empty, what time is it? It's microtask time. So we pick this up, we execute this, right? We pick this up, we exhaust the whole microtask queue. Again, we are done with the microtask queue. So what time is it now? It's task queue time. So we pick the single task queue, that is a single thing, and we execute it, right? So this is what we should have got from after this. So we have 2M1, 2M2, and 1 T1, right? So at this point, another event loop cycle completes. Then what happens next is, again, the whole thing runs, but at this time, we don't have any call stack, we don't have any microtask. So it's directly going to pick this function from the task queue, and it's going to execute this. It's going to place that in the call stack. Call stack is going to execute this. It's going to place each of them in the microtask queue, right? Because, well, promises are microtask queues. And if you're just wondering how promises and why promises are microtask queue, it's just because of the implementation. You have to check if a function is microtask queue or not. And then you see that we resolve this bad boy and place it as a recursive thing on the microtask, right? So it does not really matter, because this is going to just create another microtask in itself, and it's going to place it in the microtask queue, which is going to execute. So it does not really matter how many promises you put in there. So here we are in the call stack, and the call stack now becomes empty. And you know when the call stack is empty, what time it is. It's microtask time. So we cut and paste all these outputs just like that from here. And you see what happens now, just after this M5, what's going to happen is that this promise gets executed in the call stack, right, just like everything else. Then this actually places another microtask queue task on the microtask, right? Call stack ends, you see that we still have microtask because we run microtask till the exhaustion, right? No excuses on that. So we have again that thing, and now we are done with that. So you see that we get all these 1T1, M3, M4, M5, M6, and that is exactly what we're going to see here: 1T1, M3, M4, M5, and we do not have M6 because I believe I missed the dot 10 here. This is the wrong thing, right? Right. So yeah, I mean, I'm missed the dot 10 here, so I'm just going to remove this statement because so as to avoid the confusion. So let's just see that if this was not available at all. But if it were available, you're going to have seen the 1M6 right here at this point. Right? Let's just see that. I mean, I missed the dot 10 here, so I'm just going to remove this. This is I believe I missed the dot 10 here. This is the wrong thing, right? Right. So yeah, I mean, I missed the dot 10 here, so I'm just going to remove the statement because so as to avoid the confusion. So let's just see. That if this was not available at all. But if it were available, you're going to have seen the 1M6 right here at this point, right? So anyway, because that promise never resolved, that is, we never run the 10 on that. That is why that console log never showed up, because that was never moved to the microtask queue. So anyway, that's fine. But here we are. So the next thing again is to pick each of these tasks one by one in single iterations. So we have 1T2 right here, then 1T3 right here, then 2T1 right here. And yep, we are done with these much tasks at the moment. Then we pick up this whole block of next thing, and just like I showed you what happened earlier, each of them would move to microtask and then they would be executed, right? So we can displace it if you want, but we know what's going to happen. And obviously I'm just going to get rid of this because we did not wait dot 10 here, that means it was never executed. So I'm just going to get rid of this, and we get rid of this as well. And finally, microtask you again once on next iteration, and each of these tasks are nicely and easily district matches from the initial. So we have 2T3, 2T2, 2M5, M4 entry, 2T3, T2, M5, M4 entry. Then we have 2T1, 1T, 1T2, 2T1, 1T, 1T2, right? So yeah, 1M5, M4 entry, and 1M5, M4 entry. Yep, it all matches up, right? So yeah, I mean, I hope you get a better understanding from this. And in the next video, we're going to be discussing what would happen, what would be the output, and explaining the output if you click on this programmatic button, that is the button 2. So that's all for this video. Hopefully you learned, just cleared up your doubts from this one as well. If not, obviously you can just participate in the discussions below. I hope somebody would answer. I would answer you. I would get back to you. So yeah, that's all for this one. I'm going to see you in the next video really quick. Alright guys, welcome back, and in this video I'm going to be doing the hardest thing, that is the second button click, and it's going to be covering a lot of things, and I'll be doing it in the nicest way possible. So let's start and let's get into this, how this would all work. So let's just go ahead and let me just go ahead and click on this button, and you see that right away you see that the output is different from the click me button. If I click on the click me button, you see we get these two separated with two microtask queue tasks, but the programmatic button there's nothing like that, and the output kind of differs here as well. So why is that? But what really happened? Let's just take a look. So starting off with the actual thing, what's going on in this button? Well, you see what happens when you click, just like I said, when you add an event listener of click to this button, and the event listener is scheduled work. When you click on this button, that is this click me button, JavaScript would asynchronously put that event listener on the task queue, that is scheduled work and scheduled work. When you click this was the initial state, right? But when you click it programmatically, JavaScript synchronously does that thing. What's the difference between asynchronous and synchronous? Asynchronously means that JavaScript would make use of the queues, the task queues or the microtask queues or whatever queues they were. Synchronous means it's going to push it to the call stack, right? It's going to push it, to the urgent thing which needs to be executed now. So what's going to happen is that when you click on this button, when you click on the button 2, JavaScript places this function. Well, yep, it just places that function on the task queue. Just like it did with the schedule work and schedule work again. No exceptions to that. But when it brings it to the call stack for execution, what's going to happen? It's going to execute this function right here on the call stack, that is button.click, synchronously, right? Last time when I was clicking this, there was no button.click function here. There was just schedule work and schedule work again. No button.click, right? But this time there's a button.click as well on the call stack because we've manually called it. That was not invoked by JavaScript internally. So in this case, when I call button.click, obviously it's going to invoke the listeners, but this time you see that it's not going to go to the task queue. It's directly going to come on the call stack. Why? Because button.click directly calls the event listeners. So schedule work never goes to the task queue in this case, it directly comes to the call stack. And when this happens, what's going to happen? Schedule work never, no button.click, right? But this time there's a button.click as well on the call stack because we've manually called it. That was not invoked by JavaScript internally. So in this case, when I call button.click, obviously it's going to invoke the listeners, but this time you see that it's not going to go to the task queue. It's directly going to come on the call stack. Why? Because button.click directly calls the event listeners. So schedule work never goes to the task queue in this case, it directly comes to the call stack. And when this happens, what's going to happen? The whole thing runs again, just like previous time, but with a very, very minor change, and that's going to make a lot of difference. So let me just go ahead and place them really quick on the microtask queue because we know about this. Set timer is going to be on T1, and then we have this whole little block of 3 promises inside the task queue as well, right? Then we have T2 and T3 in the task queue as well. And then finally, what's going to happen is we're going to get this hello world, hello from the main thread in the output because, main thread is main thread. You're going to get that output anyway. So you can see that's the first line for our output, right? Hello from the main thread. Now, at this point, schedule work ends, right? That means it's taken away from the stack, but see that call stack is not empty. That is the difference. Remember, I told you that microtasks and task queues and everything only once when call stack is empty. But in this case, call stack is not empty. So JavaScript is not going to run microtasks or tasks, right? It's going to keep on executing the call stack first so that it becomes empty or it exits or whatever. At this point, the next thing button.click calls synchronously is the second listener, right? Because, that's what we did. We attached 2 listeners here. And then again, the whole thing happens. So we get 2M1, 2M2 on the microtask queue. They just keep on building, not really executing. And this 2T1 also happens right here. Then we have this block of 3 promises, which is placed as well. Then we have 2T2 and 2T3 can speak. 2T3. There we go. So we have this many things on the task queue. And then finally, main thread is main thread, right? So we get that output directly. That's why you see the main thread, hello world from the main thread number 2 directly after number 1, because the call stack was never empty for the microtask queues to be executed. And that's it. So at this point, schedule work again empties, exits. Button.click has done its job, so it exits as well. Call stack is empty. Call stack is empty, that means it's microtask time. And you know that microtasks never leave before executing the whole thing. So what's going to happen, it's going to pick up each and everything, and oops. Yep. And it's going to write everything. 1M1, it's going to pick the next one. 1M2, it's going to pick the next one. 2M1, and it's going to pick the next one. 2M2, right? And there we have it. The microtask becomes empty. So you see that we have hello from main thread, hello from main thread, then 1M1, 1M2, 2M1, 2M2, just like we predicted, right? At this point again, microtask is empty, so event loop runs the next thing, which is the task queue. So it picks up only a single task, runs it, completes the cycle, and in the next iteration it runs this whole block, which is going to place all of these things on the microtask queue, right? 1M3, 1M4, M5, just like that, right? And I hope that's it. So that is done. And yeah, only one task in a single iteration. Then it runs again, the event loop runs again. It sees microtask is no longer empty now, so it's going to execute the whole thing as quickly as it can to its full completion to make it empty. There we go. 1M2, 1M1M2, 2M1M2, 1T1, M1M2, 2M1M2, 1T1. Then we have 1M3, M4, M5, 1M3, 1M4, 1M5. That's fine, right? So it's working. Again, microtask is empty. We pick up a single task again and again and execute it in a single, in individual event loop cycles. That is 1T2 is another cycle, 1T3 is another cycle, 2T1 is another cycle, right? And then in another cycle, we're going to be executing this whole block, which is going to place 2M3 in the microtask, 2M4 in the microtask, and 2M5 in the microtask, right? And we get rid of this whole block. So at this point again, microtask is not empty, so it's going to, JavaScript is going to exhaust that first. 2M3, 2M4, 2M5, and I just placed that 2M3 as well, so I'm going to remove that. And finally, nice and neat, there we have it. 2M2, 3, 1M4, 1M5, that is it. 1T2, 2, right? So we have calculated the expected output in a correct way. I hope this actually cleared a lot of doubts about you, about your event loop knowledge as well. There are just a little bunch of things you need to remember for the most part. Number one thing is that microtask queues and task queues are never executed as long as there is something in the call stack. Number two, microtask is executed before task queue and is executed to death. That means it would keep on executing unless the whole microtask queue is empty. And number three, task queue executes only one task in a single iteration of the event loop, right? So it's only going to pick up one task in a single whole iteration, but microtask queue on the other hand would completely execute the whole queue as soon as it finds that. So yeah, I mean, that's pretty much it. I hope this is useful to you. That's basically the highest advanced JavaScript knowledge you can get, theoretical, in terms of event loop, because you now have a very good picture of how event loop works, how the execution order works, and hopefully you would be able to debug some of the nastiest bugs you might ever see in your life with JavaScript. Right now, not really all bugs, but just where the execution order is critical and you're not able to figure out how the execution is really working in a single-threaded JavaScript. So this kind of makes it very interesting. So that's all for this video. I hope you liked it. If you did, I'm going to see you in the next one real quick. What's up?
Hi, Jira. We brought you here.
The transition property defines which property the transition effect should be applied to. In our hover state, we are only using the transform property, so in here we can say transform. The transition duration defines how long the transition effect should take to complete. I'm going to set it to 0.3 seconds. The transition timing function defines the acceleration curve for the transition. The common possible values that go in here are ease in, ease out, ease in out, linear, and ease, which is the default. The transition delay defines the delay before the transition should take effect. I want my transition to start the moment the element is hovered on. So the transition or hover by using the transition. In my HTML, I have a button with the class of button. In my CSS, I have the styles for the button, and I also have a hover state. In my CSS, CSS to create a transition, we first need a component that has a change in property in my Hello, what's up?
AI is changing the game for app development. Firebase is here to help. We offer a platform designed to support you throughout your app and business's journey, so you can rapidly build, release, monitor, and optimize.
You might be wondering why there's a chameleon in the thumbnail of this video. A chameleon can change its color and pattern, adapting its appearance to match its environment. The chameleon's ability to quickly and seamlessly change its appearance is a skill to be admired, and what I'm suggesting is that we ought to be more like the chameleon when creating our responsive layouts. You've built yourself a header component. Your header has a title on the left, a menu in the middle, and a sign up button on the right. Your header looks good on large viewports, however, when you resize the page, eventually your header breaks. You need a way to add styles on smaller viewports. This is exactly what media queries do. They allow you to target specific viewport sizes and apply styles on them. Resizing the page, we see our header breaks on a width of 1231 pixels. The type of media query is at media, etc. If I search and apply style all by once we go above 500 pixels. If you design your website desktop first, then you would website media queries work of 0.5 RAM. You could instead use the shorthand margin property and set it to 0 auto, but because this is a utility, the shorthand is constantly shrinking. The containers on this website were created using the popular width of 90% and margin of 0 auto. Once upon a time, I was making a website for a client. The client had a designer, and this was the design they wanted me to code. It was pretty standard, almost everything is Flexbox, and the idea was that the website was floating in space. Then the designer thought that his design needed more space elements, and so he sent me 5 images that I was supposed to position in strategic places to deepen the illusion of being in space. Positioning these images directly on the page would break the layout, so I needed a way to position them without moving other elements around. To start using CSS positions, we first need some elements in our HTML. All I have is a div with the class of container and 2 some base styles in a separate CSS file. None of this is relevant to CSS positioning. You don't need a container with 12 items, and you don't need a grid to start using the CSS positioning properties. All of this is just for demonstration purposes. In a fresh CSS file, I'll select the first item in our grid by its class name and give it the position property. In total, there are 5 position values for demonstration purposes. In a fresh CSS file, I'll select the first item in our grid by its class name and give it the position property. In total, there are 5 in our just for demonstration purposes. Property relative on our 3, 4, 5, and so on, but we don't see item 2, and this is because it's hidden underneath item 1. To move item 1, we can use the top, right, bottom, and left properties. These properties are unlocked when we assign a Hello, how's it going everyone? I just wanted to say that I just created a Discord server. If you want to join it, you're more than welcome. You can find the link in the description of this video. We're building a portfolio website. This portfolio has 7 sections: a header, a hero, an about, a featured project, more projects, a contact section, and a footer. The website is entirely responsive, mobile first, and only has 6 breakpoints: 475 pixels, 640 pixels, 768 pixels, 1024 pixels, 1280 pixels, 1536 pixels. Clicking on the sun icon lets us toggle between light mode and dark mode. We're using local storage to save the theme, so if I reload the page, we see we're still in light mode. And if I switch to dark mode and reload the page, we see we're still in dark mode. Scrolling down the page, we see the images below the fold are all lazy loaded and are all accompanied with a blur animation. Towards the end of this video, we push our code into a GitHub repository and then we deploy the website to the World Wide Web using Vercel. If you want to look at the website yourself, you can find the link in the description of this video. Before we start, if you don't already have Node.js installed, then you're going to have to install it. Head over to nodejs.org and download the LTS version. Second, if you don't already have Git and Git Bash installed, then you need to install them. Head over to git-scm.com and click on Download for Windows. Finally, if you're on Windows, the default command prompt and PowerShell terminal are just not good enough. Open your Microsoft Store, search for Windows Terminal, install it, and open it. Click on the small arrow and select Settings. Scroll down and click on Add New Profile. Click on New Empty Profile and change the name to Git Bash. On the Command Line tab, click on Browse, enter into your local disk, and open Program Files. Find the Git folder and open it. Open the bin folder and select Bash. Change the default directory to whatever you want. I'll select my desktop. For the icon, go back to the Git folder inside your program files, go in the Ming W64 folder, go in the Share folder, go in the Git folder, and select the Git for Windows icon. Click on Save and go back to the Startup section. Change HTML. I have a button with the class of button in my CSS.
To introduce a website and can be a great opportunity to help people quickly understand what it is your site does. For many visitors, it'll be their first impression of your brand, so you'll want to make the most of this moment to present something that properly shows how great it is. A hero header is the place to feature large, striking images or videos explaining your site. These look great, but there's This makes the site take longer to load and can slow things down. This is particularly noticeable on slower connections, which is a problem many of us developers tend to forget about if we're lucky enough to be building our sites while plugged into fast broadband. Studies have also shown that shaving seconds from the load time of sites has a great impact on the perceived quality of the site. If we make use of CSS, we can create impressive animations. Lastly, the animation and transition properties are built into our browsers.
Yo, what's happening guys? Welcome to CSS Animations Lesson 1. Hello. So what is a CSS animation? Well, basically, a CSS animation makes it really easy to animate web elements. Yo, what's happening guys? Welcome to CSS Animations Lesson 1. So what is a CSS animation? Well, basically, a CSS animation makes it really easy to animate web elements on your website without the need to use JavaScript.
Alright, hi everyone, welcome to the CSS Animations course. So before we get started, I'm going to create this video to kind of run you through what we're going to be doing in the course. So I'm going to go through section by section and explain the skills we will be learning. And I'm also going to explain a little bit about the course structure, how things work, so you can really get familiarized with everything before we go ahead and start. So first of all, let's talk about what you're going to learn by the end of this course. So you're going to know the basics of CSS animations. You're going to be able to apply it to real-world scenarios and use it in a variety of situations. You're also going to be able to use or do the same with transitions and transforms. So we're going to learn a ton of effects and CSS properties to be used with these animations. We're also going to learn how to make these animations compatible across browsers and user-friendly, so you can really make the best out of them. So the main way that the course works is that it's split up into sections, with each section focusing on a single topic. So for example, one section will be focused on animations. Each section is going to have these tiny challenges in each video to kind of test the things that you learn in those videos, but then there are also two extra challenges at the end. One is just a large normal challenge to test your understanding and to really get you familiarized with the structure, and then a real world challenge that helps you apply those skills to a real scenario. So we'll see a couple examples of those in just a second. So before we get started, I'm just going to give you some warnings about the course. So the initial challenges that you're working with, especially in the videos and the non-real world ones, may seem a little bit easy and kind of remedial, but that's what they're kind of intended to do. They're meant to build some muscle memory for those skills so you can really get used to them, and when you do end up having to use them in proper situations, you'll be ready. Another warning is just with the playback window. HTML and CSS renderings are going to be played in real time. So if you speed up the video, or pause it or skip through it or anything like that, just beware that it will still be playing in real time. It won't be playing with the video. So let's go ahead and get started. The first section is going to be focused on transitions. So we're going to learn what they are, where they can be used, and how to actually apply and work with them. So the main single normal challenge to get you used to it is just to create and apply a couple of transitions from scratch. And now the real world challenge, which is the fun part, is to take these transition skills and apply them to a website where you can see we have this menu here. We have a couple of hovers and grow features that you can see here. The next section is going to be focused on animations. So we're going to be, again, learning what they are, how they work, and we're also going to be learning about these special features that come with animations called keyframes. So we're going to be learning how to use those, and then we're going to go ahead and customize our animations. So just like before, the challenge or the main challenge is going to be to just create and apply an animation from scratch. This includes writing the keyframes, applying it, and customizing it. And then our real-world challenge is to create animations for a landing page. So it's pretty common to see animated landing pages, especially for newer sites. So we're going to be putting our skills to the test and actually working with them. You can see this a little GIF here. You can see that we have a nice animation in the background with an expanding background and then some faded in text. So that's what we're going to be doing in that section. The next section is going to be focused on effects and transforms. So these aren't actually focused on animations directly, but they are very useful when it comes to animating things, and even outside of animations, just general CSS. So we're going to learn the various types of effects or transforms that we can use, and then we're going to be applying and integrating them into our animations and transitions. So both of these challenges, these large challenges, involve the animation skills we've learned in the previous section, which is actually a great way to retain what you've learned. But what we're going to be focusing on is creating animations, and it's not really the animations that we're focused on, but what goes inside them. So the challenge is going to be to create and apply these animations using those effects that we learned in this section. And then the real world challenge is going to be quite similar. We're going to animate a logo. We're going to be creating an animation using those effects, and then apply those to a logo. You can see that here. We have a little animation that goes back and forth. So we're going to be doing that in this section. So the final section is quite unorganized. It's not really focused on a single topic. It's just those outlier videos that you can really put in any other section. So these are still very important skills. I highly recommend you watch them. Things like browser compatibility and streamlining your style sheets are all included in this section, although there won't be any large challenges. There will still be those tiny challenges that, those mini challenges that test your skills at the end of each video, but there isn't going to be any large real world scenario. All right, let's get started. Hi, welcome back. So in this video, I am going to be talking to you about working with the Scrimba workspace and really using the course to its full potential. So I'm going to be going through and explaining what all of this does, and we can see all the different components of this window and how you would use them. So the first thing I want to talk about is the interactivity of this platform. Now you can go ahead and interact with the code that I'm writing at any point.
हेलो एंड वेलकम टू अपना कॉलेज, दिस इज दी वेब डेवलपमेंट कोर्स, और आज के इस वीडियो में मैं आपके लिए एक
Are you feeling overwhelmed by CSS animations? If so, this is the perfect video for you, because I'm going to break down everything there is to know about CSS animations. And also, if you're feeling stuck with CSS selectors or confused about all the selectors that are out there, make sure to check out my full CSS selector cheat sheet down in the description below. It's going to give you all the information you need to know about selectors. Let's get started now. Welcome back to Web Dev Simplified. My name is Kyle, and my job is to simplify the web for you so you can start building your dream project sooner. So if that sounds interesting, make sure you subscribe to the channel for more videos just like this. Now to get started, I have just some really basic HTML and CSS. I have a parent and a child div, and as you can see, the parent is outside the child, so the child is inside the div. And this parent has this dark blue color, as you can see on the right, and this child has the red color. And then whenever you hover over the parent, all I'm doing is transforming the child. So essentially I'm moving it all the way to the right side of the parent and back again, depending on if it's hovered or not. Then we want to talk about animations, because right now, this is really jerky. There's no smooth animation between these different states. And in CSS, there's two different ways to animate. You can use the transition property, which is simple and works great for doing simple animations, and then there's the full-on animation property, which is a bit more complex, but is great for making more complex multi-step animations. In this case, we're going to get started with transition and then move on to animation, because this can be done by just a simple transition. So how do you go about writing a transition? Well, all you need to use is the transition property in CSS. And the first mistake most people make is they put the transition on the hover, or the place where the transition is happening. But in our case, when we're hovering over the parent, the transition will be applied, but as soon as we unhover the parent, the transition will be removed. So where you need to actually put it is on the child itself. And I'll show you why once we get the transition written. So in order to write a transition, you can just write out the word transition. And as you can see, there's multiple transition properties. There's timing function, property, duration, delay, and then just the transition keyword itself. This is just like with margin, how you have margin left, right, top, bottom, and then the margin keyword that has all of them combined into one. Transition just combines all four of these properties into one. And it's generally how you're going to write transitions. So by default, a transition is going to transition all of the properties on your element. It'll have all written here. But we really only want to transform, or transition or transform here. So we're just going to write transform. What this does is tells our CSS we're only wanting to animate this one single property and nothing else. So if our color changed, for example, it wouldn't actually be animated. And then what we need to do is specify how long this animation will take. You can say 100 milliseconds, for example. In our case, we're going to say 1 second. And this is all you really need for a transition. If we save this and hover, you'll notice our box moves to the right over 1 second. We unhover and it moves to the left over 1 second. And if we get rid of transform here, you'll see that it still works because it just defaults to animating all of our properties. So if we were to, for example, change our background color here, color to green, you'll now see it transitions slowly from red to green as it goes across the board. But inside of here, if we just wrote transform, you'll notice that now our color transformation is instantaneous, while the actual transform itself is being transitioned back and forth over 1 second. So this is great for specifying individual things that you want to transition and other things that you don't. So now I want to show you why the transition isn't put on the hover version. So if we come over here and put transition on the hover, just like this, and I see when I hover over this object, you're going to notice it transitions really smoothly. And that's because I'm currently hovered, so I have a transition being applied. When I unhover, you'll notice it instantly moves the element back. And that's because this transition property is no longer set on the child, because this hover state doesn't exist. It's as if this was not here, so there's no transition being applied to the child itself, so it doesn't do that smooth animation. This is why when you specify transitions, you always want it to be on the base class, in our case this .child, and not the actual modified class of hover in our case. Now the last two things that we can do with this transition property are specify a delay. delay, as well as a timing function. The timing function is a transition property. You'll notice it just like this, and I see when I hover over this object, as if this was not here. So there's no transition. Being applied to the child itself, so it doesn't do that smooth animation. Is it here? You'll notice that now our color transformations here, it transitions slowly from red, wanting to animate this one single property and nothing else. So if our color changed, for example, it wouldn't actually be animated. And then what we need to do is specify how long this animation will take. You can say 100 milliseconds, for example. In our case, we're going to say 1 second. And this is all you really need for a transition. If we save this and hover, you'll notice our box moves to the right over 1 second. We unhover and it moves to the left over 1 second. And if we get rid of transform here, you'll see that it still works because it just defaults to animating all of our properties. So if we were to, for example, change our background color here, color to green, instead of here, if we just wrote transform, form itself is being transitioned back and forth to things that you. So I have a transition being applied. When I unhover, you'll notice it instantly moves the element for state of, so it doesn't do class, in our case this dot child, and not the actual specify a delay, as well as a timing function. The timing function is essentially determining how your different animation is going to play out. For example, we could put linear as our timing function, and this means that there's going to be even spacing between the beginning and end of our animation. Each of the frames of our animation takes the same amount of time, so our object moves linearly from one side to the other. If we did, for example, ease in, out, what this is saying is start out slow and end slow, and in the middle be slightly faster. So if I save this and hover, you're going to notice the animation starts out slow, speeds up in the middle, and then slows down at the end. And the same thing on the way back. And if you want to really take this and customize it even further than just using these few preset values, what you can do is we can just inspect our element here. We have our child. And if you come down here where it says transition, you'll notice it has this little squiggly line next to your ease in, out. Click on this and it'll open up an editor for you where you can actually edit the exact curve. And this is the path that your element is taking. So here this is ease in, out. This right here is another type, and we can kind of cycle through a bunch of different preset ones. Or what we can do is drag around these handles and create our own. So for example, if we wanted the thing to bounce, we could drag this here so it goes past the top and it's going to bounce back. And if you see this ball up here, this is essentially what our animation is going to look like. So if we do this, it's going to start out slow, speed up, bounce over the top, and then come back. We'll just copy this cubic Bezier down here. You almost never write these by hand. These editors built into the browser are perfect. So we copy this and just replace this keyword, ease in, out, with that cubic Bezier. Now when we save, when we hover here, you're going to notice it starts out really slow, and then it jumps past our ending value. As you can see, it jumps past the end and then comes back to the final resting position. This is how we can write these custom cubic Bezier curves in order to further take our animation to the next step with these really cool timing functions. And then the last thing we can do with these transforms is specify a delay. So let's just say we wanted to delay for 3 seconds. Now when I hover over this, it's going to take 3 seconds before the animation actually occurs, and then it's going to move. Same thing when I release it, it's going to take 3 seconds, and then it's going to start the actual animation itself. Now, unfortunately, that's pretty much all that we can do with transition. We can't get any more complex. For example, if I wanted to take this cube and move it from the top left to the bottom left, the bottom right to the top right in kind of a circular motion, I couldn't do that with transition because it requires multiple different steps, which is where animations come in. So what I'm going to do is show you how to take this current transition. We're just going to simplify this a little bit. We're going to change this to ease in, for example, just so we have a little bit of a simpler transition. I'm going to show you how to take this transition and convert it over to the animation syntax, and then how we can take that a step further and make this circle around our cube here. So to convert a transition to an animation, all we need to do is write out the word animation. And with animations, you write it in the place where you want it to happen, in our case, here on our hover. So we write out animation. As you can see, animation has a bunch more properties than the transition does. You can see it has all these different properties, and then the animation keyword, which combines all of them together. And generally, you'll just write everything in the animation keyword because it's much easier. Now, the first thing an animation needs is a name. This can be anything that you want. It's just a custom name so you know what this animation is. We're going to call this left to right, because that's what it does. It moves from the left to the right. Then, just like with our transition, we can specify our duration, in our case, 1 second. We can specify a timing function, in our case, ease in. We could even specify a delay if we wanted that 3-second delay, but we're just going to leave that off for now. So this right here is all of the code for our animation complete. How do we actually write out our animation? We gave it a name, but where do we define that name? Well, that is where keyframes come in. So we just come down here, type in @ and then keyframes. This is just like if you did a media query. You put the @ symbol and then the word keyframes, and this has to be outside of any selector. It's on its own. Then we put the name, in our case left to right. Again, this can be anything you want. It just has to match your animation's name. This is how they get linked together. Then we put a set of curly braces, and in here is where we define our keyframes. And keyframes essentially determine what our animation looks like at all of the values between 0% and 100% complete. So in our animation, at 100%, we want to have this transformation. We can say 100%, and we can just copy in here our transform translate x to 100%. This is what our animation looks like at 100%. And by default, if you don't specify anything, for example 0%, it'll just default to whatever the values here are for our child itself. So right now, if we save this, we should get the exact same animation. If I hover, you'll notice it moves over to the right. But you'll notice something weird. As soon as it gets to the right-hand side, immediately the animation jumps back to the very beginning. Let's try that again. We hover, it gets to the right, and then immediately it defaults back to where it was at the beginning. The reason for that is that animations, what happens is they do everything inside of their keyframes. In our case, all we have is 100% because our 0% is this default up here. And it's saying, okay, do all of this animation, and as soon as the animation's done, it removes all of the properties it added. So it goes back to whatever the default is here inside of child, which in our case, our translate is not applied, which is why it's in the default position. If we wanted to, for example, keep this transform and keep this extra translate, what we need to do is tell our animation that. So what we can do inside of animation is we want to say that this animation is forwards. This property is called the animation fill mode. This can either be the backwards, both, or forwards. And really all this is saying, if you specify backwards, it says before my animation starts, apply all the properties at the 0% keyframe, which we don't even have. If we specify forwards, it says after my animation is done, keep all of the properties inside of the 100% keyframe. And finally, if you use both, it'll essentially combine backwards and forwards together. So now if we save this and hover, it's going to move to the right and it's going to stay there because this forwards keyword is saying I want to keep all the properties in the 100% keyframe, so it's keeping this transform here. Another really important thing about CSS animations that most people don't think about is performance, and it's actually really easy to make poorly performing CSS animations. So I made an entire video about CSS animation performance, which I'll link in the cards and description down below. So now I want to take this a step further. As I said, I want to move it around here in a circle from top left, bottom right, top right. But how would we go about doing that? Well, let's just come in here. We're going to write out different keyframes. We're even going to define our 0% keyframe, even though we really don't have to. And we're going to say transform translate x, and we want this. v0. This is going to be our default value. And description down below. So now I want to take this a step further. As I said, I want to move it around here in a circle from top left, bottom right, top right. But how will we go about doing that? Well, let's just come in here. We're going to write out different keyframes. We're even going to define our 0% keyframe, even though we really don't have to. And we're going to say transform, translate, x, and we want this to be 0. This is going to be our default value. And 100%. And we want this to be in that top right corner, so this is already correct. Now we need to define our intermediary keyframes. So we're going to have 33%, and we're going to have 66%. So at 33%, all we're going to do is take our transform, we're going to translate the y direction 100%. This should translate us down 100%. And let's just save this and see if this works. If we hover, you'll notice it moved us down that 100%, which is what we expected. Then at 66%, we need to essentially have our transform contain both our translate x of 100% and our translate y of 100%. That should correspond with the bottom right-hand corner. And now if I say that, we should get this box moving in a circle. So if I hover, you can see it moves all the way around our square from top left all the way to the top right in order from top left, bottom right, and top right. And if I remove and go back, you can see that it is doing that full loop again, which is exactly what we want. So right now we've pretty much only taken what we can do with the transition and then slightly improve upon it by adding additional keyframes inside of here. But we can actually do so much more with animation. And let's just remove this transition up here. This hasn't been doing anything, but just to be super clear that we're working with just our animation. animation. There we go, it's working as expected. But with animation, we can go a step further than just doing a complex animation. We can also tell our animation how many times to repeat, the order we want to run the animation, and so many other things. So for example, we have something called an animation iteration count. We can say how long we want the animation to be repeating. We can say 3, for example. This is going to cause our animation to occur 3 different times. So if I hover, you can see it moved around, around, and around. And right now, it's doing this little jarring thing where it jumps back to the beginning, repeats the animation, jumps back, repeats the animation. If instead of doing that jumping motion, we wanted to make it go around, and then back, and then around, we could specify the direction of our animation. And there's a direction called alternate, which essentially just says when I get to the end of the animation, for the next iteration, go backwards. So if I hover this, you can see that it's moving back and forth, and it does that 3 total times. 1 time forward, the second time goes backwards, and the third time goes forward. We could also specify a delay here, and as long as we put it after our duration, doesn't matter, we could just come in here and say, we'll do 3 seconds. So when I hover, there's going to be a 3-second delay, and then our animation is going to occur, as you can see, and it does it 3 different times, and then it stops. So we can combine a bunch of different stuff with animations, but we can take this a step further. Let's say that we want this animation to occur infinite times, with no delay, and instead of doing this on hover, we actually want this animation to be permanent. So we'll just put it up here, and now when I save, you'll notice that this just does the animation over and over and over again, and since we're doing it infinite times, it's never going to stop. But we can actually make this animation play and pause based on something called the animation play state, I believe it's called. Animation play state. And this determines whether the animation is running or paused. We can set it to be paused whenever the hover state is active. So now, when the animation is running and I hover, it'll immediately pause the animation. Unhover, and it'll continue, and hover, and it stops. And it'll stop wherever in the animation I am whenever I hover, because I'm setting this play state here to paused. Running is just the opposite of paused. It's essentially the default. It means the animation is currently occurring. The final thing that I want to mention, we just change this back to paused, is that inside of these keyframes, you can do whatever you want. For example, I could change the background color, start it out at red, and then jump all the way down to 100% and say the background color is green. Now if I save, you'll notice throughout the animation it's changing from red to green. And even though I didn't supply a background color in this intermediary state, it's just saying from 0% start at red and then slowly animate all the way to green at 100%. And if I threw something in the middle here, for example 50%, I could say background color of blue. Now what's going to happen is it's going to animate from red to blue. The blue will be right in the dead middle here. If I hover, you see it's blue right in the very center. It'll go to green, back to blue and red, and it'll do that over and over and over again. You can do a lot of really cool things with these keyframes. Essentially what happens is it just does a transition between each one of these keyframes. That's really all that's occurring. And that's all there is to animations in CSS. If you enjoyed this video, then you're going to love it. Essentially what happens is it just does a transition between each one of these keyframes. That's really all that's occurring. And that's all there is to animations in CSS. If you enjoyed this video, then you're going to love my free CSS selector cheat sheet, linked down in the description, which is going to show you all the selectors you need to know in CSS. Thank you very much for watching this video, and have a good day.
So what is ClickUp? ClickUp is an all-in-one productivity software where you can manage everything and anything related to your work. Your documents, your chats, your whiteboards, your projects. The value of this, you don't have to buy 5 softwares to do this. You don't have to be hopping back and forth between multiple tabs trying to find that email from a year ago. Instead, you can find everything in a matter of seconds, keeping your work and everything related to productivity organized in a single place.
Elon Musk's brain implant company Neuralink has revealed new results from their first ever human trials. We know that Neuralink's first human test subject has already accomplished something never seen before in the world of brain-computer interface, but the company has also run into at least one unexpected problem that needs to be overcome. It's been just over 100 days since Nolan Arbaugh became the first human being to be implanted with a Neuralink N1 brain chip. The surgical procedure was conducted at the Barrow Neurological Institute in Phoenix, Arizona, which is the world's largest treatment and research hospital for neurological diseases. In those 100 days, Nolan has already accomplished some unprecedented feats. During his first ever research session with Neuralink, Nolan was able to set a new world record for human BCI cursor control. That was day 1. During weekdays, Nolan spends up to 8 hours a day contributing to Neuralink research sessions. On weekends, his personal and recreational use of the implant can exceed up to 10 hours per day. He's been able to reach up to 69 hours per week of brain-computer interface with the N1 chip. The standard for measuring speed and accuracy of cursor control is bits per second, or BPS, and that's what Neuralink is calculating during these grid tests, where you see the cursor moving around and clicking on different boxes. On day 1, Nolan set a new world record of 4.6 BPS. 3 months later, Nolan is already achieving 8 BPS and is quickly approaching the same speed and accuracy of an able-bodied person using a mouse with their hand, which is 10 BPS, so he's close. The Neuralink telepathy software is able to distinguish between left and right clicks and allow for movement of the cursor that is precise enough to click on the smallest icons and buttons of a laptop screen. The real-world result of this technology is that Nolan is able to use his thoughts alone to complete tasks that previously required his mouse stick, literally a stick that he holds in his mouth and uses to interact with a device. After 8 years of living with full-body paralysis, Nolan had become very proficient with using this physical control in his daily life. He even told Neuralink, quote, "I thought that the mouse stick was a lot better than BCI a month ago. When we compared them, I saw that BCI was just as good, if not better, and it's still improving. The games I can play now are leaps and bounds better than previous ones. I'm beating my friends in games that as a quadriplegic I should not be beating them in." Not only can Nolan now play simple computer games like chess and Civilization 6, he's also been able to use the N1 to play Mario Kart on a Nintendo Switch console, which is even more than I would have expected to be possible at this early stage in the game. It's important to remember here that the aim of the initial prime study is not about setting world records or beating human capabilities. The primary goal is to demonstrate that the Link device is safe and useful in daily life, so a lot of the work that Neuralink is doing is just remotely monitoring the technical performance of the device to try and measure the benefit that it provides to Nolan and his quality of life, which so far appears to be overwhelmingly positive. Nolan told Neuralink, quote, "Y'all are giving me too much. It's like a luxury overload. I haven't been able to do these things in 8 years, and now I don't know where to even start allocating my attention." Now, of course, this is a first of its kind medical procedure, so it would be expected that some things will not work out as planned, and Neuralink is no exception here. There's been at least one problem with the device that's already cropped up in Nolan's testing. So what we know is that in the weeks following the surgery, a number of the electrode threads that were implanted into Nolan's brain tissue started to retract, essentially cutting off some of the communication between the brain and the implant. During the surgical procedure, Neuralink's R1 robot was used to insert 64 threads into the outer layer of the brain, the cerebral cortex, and specifically, this is targeted into the motor cortex region of the brain, penetrating just a few millimeters deep into the tissue. Each thread is thinner than a human hair and carries 16 electrode sensors, giving the Link device a total of over 1,000 connection points into the neural network of Nolan's brain. From here, the electrodes can detect bioelectric pulses created by neuron activation within the cortex layer. The Link device uses signals collected by the threads to create a digital representation of the brain activity that can be transmitted via Bluetooth into a nearby computer device. So when the threads retracted from the brain, that decreased the number of electrode interfaces between the Link implant and the motor cortex. So losing one thread would be a 1.5% reduction in electrode count. Losing just 3 threads would be nearly a 5% reduction in brain connection. We can see the effect of this in Neuralink's own data charts. Starting late in February, the performance of the BCI started to drop off. We can see that Nolan goes from 8 BPS down to 5, then 4, and as low as 3 BPS by mid-March. But then the number recovers again quickly. Nolan bounces back to 6 BPS by around the same time period that Neuralink released the first live stream he was featured in on March 20th, where we saw Nolan able to play chess on the stream with his mind. Neuralink explains this by saying that they honed the algorithm to make better use of the limited data being collected from the brain, and we can see that Nolan is quickly back to his original performance of 8 BPS. This was acknowledged by Nolan at a Neuralink company meeting that happened on March 1st, which he posted a recording of to X on March 22nd. Nolan said, quote, "Sure, we're still working out the kinks and stuff, but once we get this figured out, there's no reason for the implants not to be out there." So this begs the question, what happened? Well, according to a report from the Wall Street Journal, Neuralink believes that some air was trapped inside Nolan's skull after the surgery was performed. This is a condition called pneumocephalus. Now, I'm not going to pretend like I'm a doctor here, but it appears like mild cases of pneumocephalus can be relatively harmless and are often resolved by the body reabsorbing the air, so this doesn't appear to pose any risk to Nolan's safety, but it does impact the potential of his current Neuralink implant. If the threads have extracted themselves from the brain tissue, then there's no easy way to put them back in. According to the WSJ report, Neuralink has already floated the possibility of removing Nolan's implant, but we have no reason to believe that this will actually happen anytime soon, though one of the upshots for the Link device is that it is intended to be removable and upgradable over time. Unnamed sources within Neuralink have said that challenges like this were expected in the first test on a human patient, although they didn't specify any reason why there would be a different result after doing the procedure on a human brain after dozens of test implants on monkey and pig brains. The Neuralink sources say that the company remains optimistic that this problem can be resolved and that future implants will be able to capture more data and offer greater capabilities for human patients. Neuralink has already reported to the Food and Drug Administration that it believes it has fixes for the problem that was encountered with Nolan's implant. According to the same same sources reported by Wall Street Journal, Neuralink already has plans for 2 more human implant procedures in the coming months. These will go forward once a safety review of Nolan's implant is completed. Neuralink reportedly maintains a goal to implant 10 people this year with the device. According to a potential roadmap from the company, that will increase to another 27 implants in 2025 and 79 in 2026. In 2021, Neuralink performed a total of 155 surgeries on sheep, pigs, and monkeys. In 2022, that number grew to 294 total surgeries. So it's expected that the first human trial will take up to 6 years for Neuralink to complete and verify their findings. The primary study period will take place over the first 18 months after the device has been implanted. Patients will check in with a medical team every 2 months to monitor progress and ensure the Neuralink device continues to work as intended. In the meantime, make sure you follow Nolan on X at ModdedQuad. He's started doing live stream demonstrations of his Neuralink abilities, and it's pretty fascinating to watch this all progress in real time. Elon Musk and his team behind the Neuralink brain implant have just provided
Are you feeling overwhelmed by CSS animations? Are you feeling overwhelmed by CSS?
তুমি কি এখন
Yes, sir, bolo to.
This is my AI Gargura. She is cute.
I like cats a lot. They are very fluffy and sweet.
She is funny.
Why did the shark cross the ocean? To get to the other side.
She is smart.
You stretch the line, and that metal inside. It's that simple. You can either have a metal rod or external fixations, but you'll be very tired and in pain because you have to be awake for this operation. Okay.
She is everything I dream of. But before I tell you how she works, let me tell you a story. The year is 2016. While the West is on fire, a Japanese startup announced a very interesting project. It's called Gatebox, a waifu in a box. According to the advertisements, she should be an assistant as well as a chatbot to talk to. She was able to tell the weather as well as send the guy some messages while he's at work. At that time, everyone was laughing at it. It's absurd, it's insane, it's immoral, it's messed up. But little did I know that it's actually a product ahead of its time, and it's what inspired me to create something like this. Despite me laughing my ass off at this invention, but PP says, weeps taking out loans for their hologram wife, and Dive Math says, okay, but hear me out, the cost of entry may be high, but over the long run, restaurant, I imagine it would be cheaper than a trad wife. Hollow waffle plus tanga egg combo seems to be cheaper than years of delivery. More importantly, this will be more. It's funny because it's true. It's funny because it's true. Fast forward to today, we pretty much have the technology to do this. But let's talk about how my AI waifu works. Firstly, you just want to say something to it, and then I'm using a audio to text program to turn my speech into text. After that, I'm gonna send it over to a language model. The language model is pretty much the soul and heart of this AI. It's the program that decides on how it should respond to what I just said. Famous examples include Character.ai and ChatGPT. After I get a response, I'm going to send it over to a text-to-speech program so I can actually hear her. After that, I'm gonna get a speech-to-talking head program. This is quite complex, but pretty much you take a speech and then you get a talking head out of it. Once I get the talking head, I can pretty much use any VTuber avatar I want. And that's it. That's the program. Everything that I just explained probably went over your head, so I'm gonna have a more in-depth explanation. Let's start with the first step, voice to text, also known as transcribing. The program that I am using is called Whisper by OpenAI. It is an advanced speech-to-text program that's able to ignore background noise for the maximum quality. As well as it supports different languages and could even translate them.
Whisper est un système de reconnaissance automatique de la parole, entraîné sur 680 heures de multilingue et multiclash récolté sur Internet.
Despite it being relatively slow and hardware intensive, I still decided to use it in case I want other languages. This video is even transcribed by Whisper, so if you want to see the quality for yourself, turn the subtitles on. The programming for this step is actually pretty easy. I was inspired by this guy and inspired by this code. Thanks for that inspiration. Now that we've got the transcription of what I said, let's move on to the next step. Language models. This is inspired by this. I was the subtitles on. The programming for this step is actually pretty easy. I was inspired by this guy and inspired by this code. Thanks for that inspiration. Now that we've got the transcription of what I said, let's move on to the next step. Language models. This step is going to be the soul of my AI GF. This is the step that will decide what you would say when I tell her something. But yeah, you put text in and text comes out. There are lots of types of language models that are fine-tuned to specific things, like telling stories, program for you, tell erotic stories, and video assistant. For my AI waifu, I can't decide between GPT-3 or Character.ai because they have their disadvantages and advantages. GPT-3 is amazing as an assistant, but Character.ai is just more fun and better as a chatbot. These two services run over the cloud, which means that I don't have to run anything on my poor computer. This is a massive plus, because language models require a massive amount of computational power and hardware. For reference, it is rumored that GPT-3 takes 300 gigabytes of VRAM to run. This means that you need 12.5 GTX 4090s to run it. And these two services run over the cloud AI because they have their disadvantages and advantages. GPT-3 is amazing as an assistant, but Character.ai is just more fun and better as a chatbot. These two services run over the cloud, which means that I don't have to run anything on my poor computer. This is a massive plus, because language models require a massive amount of computational power and hardware. For reference, it is rumored that GPT-3 takes 300 gigabytes of VRAM to run. This means that you need 12.5 GTX 4090s to run it. I know I'm comparing it with consumer hardware, but it's just a lot. The programming for this step is easy. You literally just copy and paste this text and then you're done. And for Character.ai, I don't want to talk about it. So now we got our response from the AI. Now this is the part where things get a little bit sketchy. We have to take the AI's response to our question and then turn it into a voice. There are two wolves inside of me. One is telling me that this is immoral and taboo and such and I shouldn't do this. The other says, hey, funny Gargoyle, AI funny. And I think you know which side won. I want to make it clear that I'm just calling her voice was joking video and I have nothing against my image of hurt or offended. I think it's a part. It's not something like a elephant shark. The process of cloning someone's voice is simple. Firstly, you collect data, then you clean the data, then you train, and then you have a trained model. I have this other video where I showed off the process of cloning my own voice, so check it out if you want more information. It's a time-consuming process, but once it's trained, I can pretty much make Gargoyle say anything I want. I, of course, will use this responsibly. The last step is going to be the most technically challenging step. We need to give our VTuber a way to move her head as she talks. Lucky for us, audio to talking head is sort of a popular topic over at GitHub, a website where developers can dump their programs for others to use and improve upon. I found this repository where you can see a huge list of programs that people use to create deepfakes. I'm just gonna borrow one of them for my program. You should be able to take the audio and then create a moving face from it, like so.
Why did the shark cross the ocean? To get to the other time.
You can use this program to drive a live 2D model or use a program called Talking Head from a single anime image to deepfake Gura's model. The program does what it says. You can create a moving head from just a single image. With this, we pretty much have everything we need to make Gargura AI waifu thing program, whatever. Now we have everything we need to create a single anime image to deepfake Gura's model. The program does what it says. You can create a moving head from just a single image. With this, we pretty much have everything we need to make Gargura AI waifu thing program, whatever. Now let's have a test run. Theoretically, where would you go on a date with your beloved?
I honestly like the idea of staying at home and just being homebody together. You don't have to have a long fancy date in the middle of the city. Sometimes just eating food and watching a movie on the couch with someone who loves you just as much as you love them is all you need. You know?
Can you teach me how to play War Thunder?
Well, I suppose I could. But I can't guarantee we won't blow up. But if we play nice and keep our ears open, then we might just last a while.
Have you seen any interesting movies recently?
I've seen some interesting movies, yes. But most of them have been horror movies. And you know how I am with those. I'm a big baby. So I've been working on my fear of horror by watching some really scary ones. I am currently in the middle of watching a collection of Saw movies and just finished the first film. It was very interesting. Even if the beginning of the movie was a bit rough.
There are also some problems that I didn't manage to fix because I'm lazy. The time between me speaking and me hearing Gargura is actually like about 30 seconds. So each time I have to talk to her, I have to wait for 30 seconds in silence. It's very awkward, but the main reason is poor optimization and, well, I kind of have a crap PC for machine learning. The other issue is the voice. The voice is alright, but it could be better. But I think I like the metallic voice because I don't want it to be too realistic. The head movements could be improved, but the biggest thing I can improve in is cloning her entire personality, downloading her speech patterns, downloading every word she says, analyzing how she speaks, analyzing what words she uses, analyzing her personality. Well, I could do that, but it's a bit time consuming and even I have a line that I don't want to cross. But overall, I'm happy with this program. It does what it does. And I can actually run it live, so we can have some live streams with it. But this video is already quite stretching the line for a parody/research kind of video. So I'm gonna have to switch her out for something else. Maybe that other channel where I use the same technology. Can also change the personality, voice, and model of overstocking, so we can have stuff like this.
If you enjoy my videos, please consider subscribing and ringing the bell icon so you will know every time I upload a video. Thanks again for the view and have a wonderful day.
Maybe you should do what AI Charlie says.
believe me. Never had a lot of shit come easy. Had to work hard, struggle just to be me. Had to rise up just so they could see me. Did what I had to do just to feed me. And what was left over I put towards towards my dreaming. But the only thing in life that has meaning are the things you gotta work for, believe me. Take into your hands a plan, your own hands can land your own brand. And damn, I feel like no one takes accountability. They want the credibility, convincingly unwilling to put in the fucking hours it takes to get some power. Don't be fucking sour, take a cold shower, scream until you're louder, work until you're prouder, and fuck all the doubters, they're just fucking downers. I swear to God they all let me down. I always fought just to wear the crown. I'm pissed off at these fucking clowns who were all taught they deserve it now. It's only worth it if you work for it. It's only worth it if you work for it. I won't stop till they hear me now. I won't stop till I wear the crown.